All right, so let's talk about second degree polynomials. We have 2, 3, 4, 5, and 6 degree polynomials. Okay, so a second degree polynomial, we just call it that. Special name quadratic. So when you solve a quadratic, we have those three options there. So I'm going to give you three quadratics that have all three of those scenarios. A quadratic that has 0 solutions, a quadratic that has 1 solution, and a quadratic that has 2 solutions. So if I go like this, so they all start with y equals or f of x as a function in function notation. So y equals, I already gave you that example. I might as well use the same one. Or I could write like this. So there's factored form. How many solutions does that have? 0, 1, or 2? Did we see that? The factors are 3 and -1. Those are called factors. Solutions are the opposite of that. -3, +1. 2 solutions. Let's do a 1 solution. Again, I'm going to use the example I gave right there. X plus 3 squared. And you can graph these. You got your graphing calculator. You can punch it in real quick. Go to desmos.com. Go to graphing calculator. Y equals y1. And graph that. And look at the picture. And see that it touches the x-axis 1 time. No solution. Okay, so a no solution graph means that the graph is unfactorable. Because if it's factorable, the graph has solutions. If it's unfactorable, no solution. Well, sometimes your factors could be an unfactorable graph. X squared plus 5x plus, I don't know, 20. So like that. So the y-intercept is going to be this big, huge number as a super high y-axis, y-intercept. So when you solve that using the quadratic formula, your discriminant will have a high value. And so this would be a positive quadratic. I might as well write that in quadratic form, x squared plus 2x minus 3. I know that's factorable. This is x squared plus 6x plus 9. Factorable. So I have 3 different quadratics. Again, 2 solutions, 1 solution, and no solution. Okay, how do you know how many solutions there are? Again, we try to factor first. Factoring is the best. We can't factor, then we try the quadratic formula. If the underneath the square root sign is negative, if we end up with, like if I do this, -5 plus or minus square root of b squared. I'm doing the quadratic formula real quick for this one. This is what x equals. And you put 0 for y. So if y is equals to 0, okay, I'm solving that quadratic. But the original equation is a quadratic equation. And you put 0 there, we can solve. So I got x equals -5 plus or minus 25 take away 80. 25 take away 80. -55. When you have a negative underneath the square root sign, I know that's an imaginary solution. This has 2 imaginary solutions. Again, if you graph it, probably gonna look something like that. All right. Imaginary solutions. So again, step 1, I want to factor. Step 2, go to the quadratic formula to see how many solutions there are.
So when it's imaginary, we just consider it no solution.
Right. So if I say no solution, I want to be more exact, no real solution. That's the same thing as 2 imaginary solutions. So good point. Perfect. No solution means 2 imaginary solutions. Yeah.
So the one above it have 1 imaginary solution?
So this is 1 real solution. So it makes sense. If that has 1 real solution, it should have 1 imaginary solution because there should be 2 solutions for quadratics, right? So it's just a unique quadratic. It's called a perfect square trinomial. Okay. X plus 3 squared, x plus 1 squared, x minus 4 squared. They're special quadratic. But when you solve it by factoring, there's two solutions.
Oh, okay.
Okay, but they're just the same number. So there are two solutions. Instead of saying there's two real solutions that are the same thing, we just call it one real. Does that make sense? Yeah, so that's another really good question there. All right, so that's quadratics. We spent a lot of time with quadratics. We did the quadratic formula, we did completing the square, kind of a review. But like I said, if you have a good foundation of that, then it helps you with cubics. Okay, when you have a third degree polynomial. So these are all second degree polynomials. When you have a third degree polynomial, I want to write it. Okay, so we have standard form. These are all standard form. These are in factored form. So we're going to start off with factored form, and then we'll get to standard form. The way to get to standard form is you multiply it out. So I'm just going to work in factored form. So I'm going to write a quadratic that has three solutions, three real solutions. Maybe I should write it next to it like I did over there. Three real solutions. So y equals x. Let's go minus, or let's go plus 4. X plus 1, x minus 1. So again, that's called factored form. Why? Because there's factors. You can multiply that out. Do we want to see how to multiply that out? Yeah. So factored form, we can go from this to standard form pretty quickly. I'm going to multiply the second two together. I'm going to multiply these two together. X plus 1 and x minus 1. I'm going to multiply those together. So I'm going to rewrite this in standard form. X plus 4, x squared minus 1. Well, I can multiply again. There's two binomials. If you don't know, we can do distributive property. X times x. Oh, there's my x cubed. X times x cubed. Minus 1x. I distribute the x twice. Distribute the 4 twice. Plus 4x squared minus 4. Usually it goes x cubed, x squared, x number. So I'll just write it like that. X cubed plus 4x squared minus 1x. That's 4. So there's standard form. There's factored form. It's a third degree polynomial. I could factor that polynomial. We did a little bit of this, factor cubics. How do I go back to the original? That's factorable. I go backwards, go in reverse. Let's factor that out. They have an x squared in common. X cubed and x squared, there's an x squared. Factor x cubed, x squared out of that, I got x plus 4. They have a negative, they're both negative. They have a -1 in common. -1 and x plus 4. Hey, there's x plus 4 and x plus 4. This is called factoring by grouping. Y equals x squared minus 1 times x plus 4. Hey, there's x, this is called a difference of two squares. It's x plus 1 times x minus 1. I went back to the original problem. X plus 1 times x minus 1 times x plus 4. Going forwards, going backwards. It's multiplication, it's division. Factoring is a form of division. Multiplication, I'm multiplying. That's multiplication. Okay, so we got multiplication, we got division. So that's factored form, that's standard form. Going forwards, going backwards. Okay, multiplying and factoring. We can't do the quadratic formula on this because it's not a quadratic. There's got to be another way to be able to solve this quadratic and get the solutions. Good question. I'm glad you asked that because we're gonna do that at the end of this section. Like how to How can I solve this without factoring? What if it's unfactorable? A lot of polynomials, most polynomials are gonna be unfactorable. That's just the way it is. There are more polynomials to be unfactorable that will be factorable. So that's called division. Long division. We'll get the long division. So that's a cubic with 3 real solutions. How about 2 real solutions? We need 2 solutions. So I'm going to find a quadratic that has 2 solutions. So I'm going to write it in factored form. X, I'm going to use the same one we had before. Oh, double root. So look at your partner and tell them what the factors are and what the solutions are. Okay, tell somebody in the room. Okay, I know you're not in think, pair, share partners, but try to tell somebody what are the factors, what are the solutions?
-3
All right, so go back to this one if you didn't know, quadratics, just like quadratics. 3 and -1 are called factors. I factor the quadratic using those numbers. The solutions are the opposite. So the factors are +3 and -5. The solutions are -3 and +5. Something special happens at -3. If I plug in 0 here, plug in 0, and I got x plus 3 squared equals 0. And I got x minus 5. X minus 5 equals 0. So I got 2 solutions. X is 5. Add 5 to both sides. Oh, square root both sides. Square root of 0 is 0. This has double root. Oh, it looks like this right here. X plus 3, I used the same number. That has one solution. I'm writing it backward. X equals 5 is one solution, and x equals 3 is one solution. But stuff happens at 3. Or -3 thing. At -3, there's a double root. Call it double root. There's a 2 there, double root. It's gonna look like a quadratic at -3. So we can graph this now. Let's get into graphing. Sounds good. It's in factored form. I'm gonna go to -3. 1, 2, 3, put a dot. I'm gonna go to +5. 1, 2, 3, 4, 5, put a dot. I found the x-intercept. There's only 2 intercepts. So I'm gonna go back over here and get some notes. It's gonna look like this. Oh, but that's a negative. So it's gonna look like the letter N. It's gonna look like this one, but there's 2 solutions. I gotta figure out where does it bounce off the x-axis. So I'm just gonna sketch. There's a double root at -3, so it's gonna, this is the behavior, it's gonna go up, bounce off, and go back down. It's gonna go down here somewhere. So here's my arrow. It's gonna go down. How low does it go? Okay, I'll show you where the low point is at. It's halfway between these two. Okay, we did this before. Remember the halfway point, the midpoint? Add them together and divide by 2. Well, if we do that, that's 1. So at 1, that's gonna be my minimum. This graph's gonna go down until I get to x equals 1. That's gonna be my minimum point. So I can always find, I can find every point on the graph. What happens when x is 0? Oh, that's called the y-intercept. This is why we learn about intercepts, okay? One of the reasons. When x is 0, that's called the y-intercept. This line is gonna cross the y-axis. Plug in 0 up there. I don't need it in standard form. I can just plug 0 here. 3 squared is 9. 9 times -5. -45. Holy smokes. That's like way down there. Okay, my graph's going down, 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 down. It's gonna cross the x-axis. Till I get to some low point. It's gonna go back up.
What did you get? 25.
I plug in 0. Plug in 0 up here. When x equals 0, it's called the y-intercept. So we have some notes on that, we've seen it twice. Yeah, this is our third time. Plug 0 into the equation, y equals, oh. 0 plus 3 squared times 0 minus 5. 0 plus 3 is 3 squared. 0 minus 5 is -5. 9 times -5 is -45. Yeah, so it's gonna go down there. -45. And if you graph this in Desmos, if you go up to the original problem, go to Desmos and graph it. I'm going to get my graph, it's gonna be off the chart. All you're gonna see is like this picture here, it's gonna go off. And then all you're gonna see is that. Same thing in your graphing calculator. When you graph it on your graphing calculator, you're just gonna see this picture right here. That's how you find minimum and maximum. You find a halfway point. We find, they call this end behavior. What's happening in that graph? So again, this is called a single root, called a double root. What if there's a triple root? It's gonna look like. It's gonna look like that. Oh, x, I already gave this example, x minus 3 squared, or cubed. That's called triple root. What do triple roots look like? They look like the same. They look like that. Triple root, there could be triple roots. The double root bounces off the x-axis. So I got 3 solutions. Oh, we didn't graph this one. Want to graph it? I'll graph it over here. Go to -4. 1, 2, 3, 4. Put a dot. Go to -1. Put a dot. Go to +1. Put a dot. Oh, what's the y-intercept? Plug in 0. Okay, do this right now. Try to do this mentally. Plug 0 in for x to find the y-intercept for that equation. Find the y-intercept. For about 20 seconds. So find the y-intercept for this quadratic. $20. All right, there we go. I'm hearing a few people are saying -4. Hey, you might have found the trick. There's a trick here. 4 times 1 times -1. Just multiply those numbers together. Yeah? Let's multiply these numbers together. 3 squared times -5. Or here's another trick. Watch this. I already knew without doing the math, without plugging in 0, I already knew what the y-intercept was. Because we already did this. It's in standard form right here. Check out the y-intercept. Is in there. -4. I already knew the y-intercept was negative. I'm gonna go down to -4. 1, 2, 3, 4. That's the y-intercept. Hey, I know something about this graph. Gonna cross these. Gonna make the letter n. Yeah, it's a cubic. 3rd degree polynomial. It's gonna go up and go through here. Gonna come down and it's gonna go. That's gonna be a low point, and it's gonna come back up. It's gonna look like a quadratic right there. So it goes up. How high does it go? What's that maximum value? How high does it go? What's that highest point? It's a point on the graph. It's halfway between these two numbers. And it was just like what I did right over there. Halfway between these two. I'll put a dotted line. Again, we call that a line of symmetry or axis of symmetry. Yeah. So it's gonna go up until you hit that, come back up. -1 or wait, 1, 2, -2.5. So if you really want to know what that point is, plug -2.5 into your calculator. Or plug -2 in. I can plug a -2 into the original problem, or I can plug -2 in here. Find out at -2, what point is this on the graph? Go to -3, it should be the same point on the graph. Because there's symmetry in these quadratics. I put arrows on the line because it keeps going. Look back at the letter N. So I can find all the points on my graph. Oh, you know what we can do? We can make a table. We can make a table and find every single coordinate to make our graph. We're just finding important points. minimum values, maximum values, x-intercepts and the y-intercept. Really, if you only know the x-intercepts and the y-intercept, you can graph the whole thing. It's a sketch. Okay, so I would ask for a sketch of the graph. Okay, when you're doing homework, sketch the graph. So you don't have to find every single point, unless you want to. I gotta teach stats and statistics. There's a lot of decimals. 4.79264. And everybody always asks me, what do I round to? What do I round to? That's the question of the day in statistics. What do I round to? What's the round? And it's kind of like sketching a graph. Just use your best judgment. Well, I had a student that was fully terrified that he was going to fail the class and rounded to 8 decimal places on every single problem that we did the entire semester. And I saw that student the other day. He was working at the DMV. It was pretty cool. He was in my class like 8 years ago or something like that. We were at the DMV, and I still remembered him. Remembered his name. It was really cool. Like 8 decimals. He's like, yeah, that's me. But a sketch of a graph, it doesn't have to be perfect. You're just sketching the graph, but finding the x-intercept and the y-intercept are important places.
I know that the y-intercept kind of determines like the amplitude of that line, but what about the other part?
How high does it go?
Okay.
It's just a sketch,
Mhm.
right? So you can find it if you want to, but you don't have to. Right? Like this one. How low did it go? We didn't find it. I knew the y-intercept was -45, but that point is gonna be far below. It's not gonna bounce right here. It's gonna bounce at 1, which is right over here. So that adds some symmetry in. We didn't even find it. I just know it's gonna be way down there. If you're asked, what's the minimum of this graph? Well, this line keeps going. So this line will go to -50, but what is that point? Plugging 1. 1's pretty easy to plug in, isn't it? 1 plus 3 is 4. Squared is 16 times -5. Whatever 16 times -5 is. Yeah? 80.
Times -4, right?
So 3 squared, or what I do 4? 4 squared is 16 times -4. Yeah, is that what it said? 16 times -4? Oh, -4. 16 times -4. That's gonna be that. It's gonna be a number smaller than -45.
Well, why -4?
Oh, because 1 minus 5. Sounds like we're launching again. How many launches were last year? 180? 180? Yeah, it's so crazy. Sounds like a launch. Alright. 30-degree polynomials. Again, can we multiply that out? Okay, you know how to multiply that out? Let's see. Do the distributive property, distribute the first two together. X plus 3 squared will be x plus 3 times x plus 3. So multiply it out. It's x plus 3 times x plus 3. There it is. And then we're gonna multiply that times x minus 5. Does anybody want to see that? This quadratic in standard form? Yeah? Okay, so let's put it in standard form. I get rid of my cool notes over here. I've been referring to this, but where are we at? We're on 3rd degrees. We'll get to 4th degrees. So y equals x plus 3 times x plus 3 times x minus 5. Y equals. It's already multiplied this x plus 3 times x plus 3. X squared plus 6x plus 9. What works really well, the generic rectangle works on this. I'm going to distribute x squared times both of those, 6x times both of those, and 9 times both of those. That's one way. Or I can multiply x times all 3 of those, and 5 times all 3 of those. Multiplication order doesn't matter. 5 times 9, same as 9 times 5. Okay. I was going to distribute the x squared. Oh, hey, there's x cubed. Already got it. X cubed minus 5x squared. Then multiply 6x times that, positive 6x squared. Minus 30x. Yeah, so I did the 6 times those, now I get the 9. 9 times x, 9 times 5. Oh, hey, there's your -45, there's your y-intercept. Oh, we got some like terms. We did this in chapter 1. If they're alike, we can add them up. We put these together. Let's put those together. Y equals x cubed plus x squared. 5 negatives and 6 positives. Hey, if you don't know this, off the top of your head, punch it in the calculator. There's no x squareds in the calculator, so we just treat these alike. So I'm only adding that and that together. 6 take away 5. I think I usually reverse the order in my brain a little bit. My brain always mixes up numbers anyway, so I'll switch 6 and -5. 6 take away 5. Alright, and then 30 and 9. 30 take away 9 is 21. Type that in your calculator or Desmos, and type that in your calculator or Desmos, and you would get the same exact graph. You get the same line. You guys want to try it for a minute? Yeah, I'll slow it down. So you can try to graph on Desmos.com. Graphing calculator. What I'm saying is graph those two quadratic or cubics. 3rd-degree polynomials. Good, everybody see it's the same graph? Hopefully. Yeah, alright, so standard form, factor form, we like factor form. Why do we like factor form? Because that gives us the answer. That's it, that's the answer. The factors, the opposite of the factors are the solution. You might get tricked when you're working on your homework. Here's the trick. 2x plus 3 times x plus 3 times x minus 5. You put a number in front of the x. Well, 3 is not a factor. That just means 2x plus 3 equals 0. Subtract 3 and divide by 2. The solution is -3/2. Yeah. That's if there's a 2 out in front, right there. Alright, I'm gonna get rid of it just for the sake of notes. Alright. What, yeah,
If there wasn't two, would -3 still be a factor? Or no way?
no, it'd be, so the factor would be,
Or would that be the solution?
yeah, so the solution is -3/2, so a factor. How would you say? 3/2 probably. Yeah, 3/2. Positive 3/2 would be a factor. What if you have one solution? What if I erase the picture of the graph? But if you have one solution, here's an example of one solution. Your graph goes through the x-axis one time, but it looks like a parabola somewhere. Cause there's a cubic and a squared. So this is a graph. That will go like this, goes up, goes back down. It's a low point and crosses that. Something like that. The y, I can already tell you what the y-intercept is. I couldn't tell you what the x-intercept is. But the y-intercept is -3. Go to -3, put it up. Sketch the graph. How do I know what the x-intercept is? Oh, that's when y is 0. When y is 0, that's the x-intercept. Okay, that's unfactorable. So we're gonna learn how to solve that. A little later, okay? A little later, we're gonna learn how to solve that using division. Let's go 4th degree. Are we good with 3rd degree polynomials today? We got 1, we got 2, we got 3 solutions. 1, 2, or 3. If you get solved or write in fact form 3rd degree polynomials, you can also do 5th degree polynomials and 6th degree polynomials. More multiplication. Yeah. If you're gonna multiply it out in standard form, I would not ask you to multiply a 6th degree polynomial in standard form. Because it'd be something like this. Okay, this has 6 solutions. X plus 1 times x plus 2 times x. Let's put it 0. That means 0 is a solution. Y equals x minus 7. Okay. All right. We got 1, 2, 3, 4, 5, 6. That has 6 solutions. There's 6 different solutions for that. We got 0, -1, -2, 7, and a double root at 4. So it's going to bounce off the x-axis at 4. Okay, I mentioned it earlier. A triple root does that little s thing. So let me do one that has the s curve. Let me do a 5th degree polynomial that has an s curve. Y equals x cubed times x minus 1 squared times x plus 3. Okay, I'm gonna graph this real quick because we need to be able to take this and go graph it. Oh, that's a 6th degree polynomial as well. Let me go like this. Okay. 6th degree polynomial. It has a cubic. So an x cubed is gonna look like a snake. It's gonna curve like that. So let's graph. Let's go to 1. Put that. Hey, 0 is the x and the y-intercept. When you have an x squared, an x cubed, or an x squared, 0 is going to be an x-intercept and a y-intercept. Because you plug 0 for x, 0 times anything is 0. The y-intercept for this graph is 0. Maybe I'll graph that one as well. Okay. So at 0, it's going to look like a cubic. This is a positive. We haven't even dealt with negatives yet, but it just does the opposite. And we got 1 and we got -3. 1, 2, 3. For that. 6th degree polynomial. Or wait, 3, 4, 5. 5th degree polynomial. So it's gonna look like the Loch Ness monster. Yeah, sound good? So it's gonna start right here. It's gonna start down low. Because the positive, it was a negative, it would go like this. So it starts down low and it's gonna go through there. We got a single root and it goes up to some high point. Halfway between here. It's gonna be your max. Again, I can find that if I wanted to. Plug the number in. I can find all the points. I can find -1, plug -1 in there. If I wanted to. I don't have to right now. But it's gonna come down and it's gonna do something crazy right here. At 0, it's gonna make the snake. It's gonna come down, it's gonna do a little swirly and come back down to a low point and come back up. That's a 5th degree polynomial. There's a triple root at 0. Triple root. So it allows us to make a graph. If there was a double root, it just bounces off the graph. There's a double root right here. Let me do this 6th degree polynomial. I got 7, 1, 2, 3, 4, 5, 6, 7. Single root there. 0, -2. What is that? -1. And double root at 4. The graph's going up. It's gotta come back down. It's gonna double root here. It goes up, comes down, it's gonna bounce off. Goes up again. Goes through 0. Comes back up. Back down. Take a look at the graph. You verify it by Desmos, graph calculator, all that good stuff. So fifth degree polynomial, 6th degree polynomial. I'm just showing behavior at a point. The 4th degree is a weird one where it looks like it's more of a U shape. It's kind of a weird. If you graph y equals x raised to the 4th power, you'll see that picture. It looks like a parabola, just flattened like a pancake. I think that covers mostly everything that I needed you to know. We did factoring, factored that by grouping. What else do we need? Zeros, factoring, multiples, minimum, maximum. I think we got it all. So I think it's good to get into some problems and work on some stuff. Ask questions, raise your hand, talk to somebody. We can work on those for a little bit, okay? Sounds good. Or break time, yeah. So 2t raised to the 4th minus 8t cubed plus 6t squared has intercepts. X-intercepts or solutions or roots, we call them, right? The roots are 0, 3, and 1. How do you graph that? Put in 0, go to 3, go to 1. Oh, it's a 4th degree polynomial. It has a double root at 0. So it's going to bounce off the x-axis here. So it opens up like the letter W. It's going to go down, bounce off, go down. Something like that. Question, Angel.
The numbers for the factory and cheap, it shouldn't be below, shouldn't it be
Oh, -3 and -1.
no, and probably one.
Oh, -1. Okay, so if you're gonna do this one, t minus 1 and t plus 4. So if I multiply this out, just to verify, I always try to check when I do factoring. I can check to see if it works. So I multiply it out because the opposite of factoring is multiplication. So I got plus 4t minus 1t, then minus 4. So I mean, really, really close.
Oh, yeah, I was thinking.
Yeah, I think you just switch the
Yeah.
the 3 and the 4. Yeah. So good point. Yeah, there's multiple answers for factors for that. You could be +3 and +1, -3 and -1, positive -1 and +4, right? So we're looking for options for all those, yeah. So I'd multiply it out just to check, and the other catch is to graph it. Graphing, you have the answer in your hand, graph it and find the solutions. Work backwards, right? Just like a maze. You ever go to, what is it, Denny's? Or Denny's, Applebee's? They give you the little kids meal and they give you the little paper. And there's a maze on there and you work backwards, start at the finish line and go backwards. And there's only one route that you can take to get out. That's cheating. No, it's not cheating. It's finding your answer. So if I have a graphing calculator, I'm allowed to use it for my test. You're not cheating. you're working backwards, you're finding the solution, so you're saying, oh, the solutions are 0, 3, and 1. How did I get that? Because I can see that graph, I can see 0, 1, and 3 are solutions, right, on the graph, so I write it down. So I got factors. I just don't know the stretch factor was 2. So I don't know how high this goes. Like, does the graph go like this, or does the graph go like this? There's a stretch factor of 2. Do you follow that? Stretch factor of 1, stretch factor of 2.
If it's unspecified, you're just to assume that it's like 1, right? Or
Yeah. So that's a sketch, right? And that's what I talk about sketching the graph. How high does it go back up? It bounces off the x-axis. How high does it go right there? Well, I can plug in 0.5 to find out. Or I can plug in 2. How low does that go? Plug 2 up there to the original problem. Or plug 2 here. Yeah, you can make a table and find all kinds of values of the graph. Yeah.
and I don't have to go backwards in the way. So I'm thinking of-
Oh, you never done that? Oh, man, go backwards in the maze.
It's real one.
One thing that worked for me, especially when I got higher level mathematics, I knew the answer. I knew the problem, I knew the answer. How did you get there? So if I already knew the answer, because the answers are in the back of the book, this especially worked for physics. When you get to physics class. If you already taken it or you haven't. So this, you can find the solutions, all the answers are there, it's slater.com, right? That has all the solutions for all the books that are out there. Some professors just give you the answer, they're like, here's the answer, here's the questions. How do you arrive at their answer? And so you gotta know the steps. And same thing when I give you the quiz, like. Knowing the factors is gonna be part of the answer, knowing how the completing the square works. Is part of the problem, right? The how to is what I'm quizzing you on or testing you on. How did you get there? And I've been putting a couple of those on the quizzes and the tests, right? How do you do it?
Next step.
Yeah, find the next step, or find the step that's incorrect. Or find the vertex. So given that. Find the minimum, right? Not just find the intercepts. Cool. Alright, any other questions? Alright, so we got a few. I mentioned that I wanted to get you out early. It's already 8:10. Oh boy. So I want to get out early. But we're gonna do, so factoring is a form of division. So if you have a 4th degree polynomial or a 3rd degree polynomial, and we have one of the factors, we already know one of the factors. We can do division. We can divide 2 polynomials to figure out what the factors are. And once we do that, we can make the graph of the quadratic. Or the cubic, or the 4th degree polynomial. Oh, I don't know. Okay, I already know one of the solutions for this quadratic, so if you know one of the solutions, for example, I graph it. I wanna find the solutions to this quadratic, okay? Let's solve it. Let's factor it. So I already know what one of the solutions is, it's 1. Because 1 plus 2 minus 3, 3 minus 3 is 0. So one of the zeros is 1. You plug 1 into that cubic, that 3rd degree polynomial. One of my solutions is 1. So I'm gonna factor this. I'm gonna get y equals x minus 1 times something squared, something. I don't know what that is. So one of my factors is x minus 1. One of my solutions is x equals 1. So if x equals 1 is a solution. One of my factors is x minus 1. Okay, hopefully we've been talking about that quite a bit here. So what I'm gonna do is I'm gonna factor that, but factoring is a form of division. So I'm gonna divide x minus 1 into that. Okay. That's the goal right now. That's the objective. So we gotta go back in time. 6th grade, good old 6th grade. You're the coolest kid in the elementary school. Picked on all the 5th and 4th graders. Oh wait, you're not allowed to do that anymore. No more bullying. Anyways, we're gonna do division. So I'm gonna do 15 divided into 1023. Does everybody know how to divide 15 to 1023? Maybe not, but we're gonna try it. We're gonna try it just for fun. So I'm gonna put I'm gonna get 15 does not go into 10. But 15 goes into 102 a certain number of times. I might have to guess on my calculator. 15 times 6. 15 times 6. That sounds about right. Well, it's 15 times 7. 105, 15 times 7. That's right. Yeah, you're right. Oh, that's too much. That's too much. We overestimate. So you're right, 105. So I can't put a 7 here. What do I put there? Gotta be a 6. How do I know that 6 goes right there? Oh, you just know. And you just done it so many times. Well, here's why, because I need to estimate what my factors are going to be. Hey, by the way, we're factoring. Use that word. 6 times 15
90.
is not 102, it is 90. If 6 times 15 was 102, 6 would be one of my factors. Okay. So I'm using the language of algebra with this problem. So I'm gonna multiply those two numbers together. Okay. And then, oh, we gotta subtract. I gotta subtract. So I'll divide those or subtract them. How do I subtract that? 1, 2. Yeah. Everybody agree? And then what do I do? For some reason, we bring down the 3. Whoever made that up, I don't know. Bring down the 3. What's the form of division? 15 times, oh, can we do 7? Oh, maybe 8. 8 works, yeah. And we got 120. Oh, the remainder is 3. Okay, we just put an R3. Okay, that was in 6th grade, but in 7th grade, you learned something. You learned that 3 is 3/15. So the answer is 68 and 3/15. Yeah. Well, I could work backwards. Multiplication. If I multiply 15 times 68 plus 3, I get 1023. Yeah, that worked. Okay, we're gonna do all that with this polynomial there. We're gonna do long division with this polynomial. One of my factors is x minus 1. I'm gonna divide x minus 1 into that polynomial. And whatever is left over is gonna be my quadratic. It's gonna be right here. So I'm gonna do, this is called long division. The reason why we learn long division is because we can factor, it allows us to factor polynomials. Okay, so I'm gonna write x minus 1. I want to put my little thingy there, my division symbol. And I'm gonna write x cubed plus 2x squared. There's no x term. But there is an x term. We just don't see it. So I'll put a 0 there. Minus 3. Okay, there we go. You gotta have all your terms. If you're missing one of your terms, if you're missing x squared, you're missing x, you gotta put a 0. Because it's a placeholder, just like that one. 1, 0, 2, 3 is not the same thing as 1, 2, 3. 123, right? So we gotta have the 0 number as a placeholder. I want to do the same thing here. 15 goes into not 10, but 15 goes into 102. Okay. So I'm gonna divide x into x cubed plus 2x squared. Well, how in the world do you do that? So what we gotta do is we're gonna do multiplication. X times what makes x cubed? Squared. Yeah, there you go. X squared. Oh, I already gave that to you. You're gonna have an x squared. So x squared goes here. Okay, I put my, remember the first thing we did, we put the 6 on top. Then we multiplied 6 times 15 to get that number. Now I'm gonna multiply x squared times x. Well, this is why we did x squared times x is x cubed. Because we're gonna subtract x cubed minus x cubed is 0. We're gonna cancel out the x cubes, okay? Then I'm gonna multiply x squared times the -1. I'm distributing. Minus x squared, there you go. And then draw a line. Just like we did right over there with numbers. Now we're doing this with variables. We're in college algebra. We're in college algebra, yeah. All right, there we go. So now I'm gonna subtract. I'm doing this next step. I'm gonna subtract. I'm gonna take away. I'm gonna minus. I can't just minus the x cubed. I gotta right over here. I don't just do 10 minus 9. I do 102 minus 90. So 10 minus 9 is actually 100 minus 90. And then we got 2 minus 0. We gotta subtract both of those numbers. So I'm gonna subtract not only the x cubed, but I'm gonna subtract the x squared as well. What's the opposite of negative? Plus. So I'll put these together. That's 0. I don't need to write 0. That's 3x squared. Okay, I want to bring down the 0x. Bring that down. Just like we brought down the 3. I want to bring the 0x down. Okay, so now I'm ignoring all that up there. I'm only dealing with the 123 now. I'm only looking at 123. 15 goes into 123. How many times? X goes into x squared how many times? What do I need to multiply by to make 3x squared? 3x. There you go, 3x. Now I'm going to do this one times both of those. Just like we did over there. 3x times x, 3x squared. 3x times -1. Negative 3x. Subtract. Don't just subtract the 3x squared, subtract -3x. Minus plus. I do the opposite. When I subtract both. Okay, I'm going to add these together. 3x. Drawing arrows. Like in 6th grade math, yeah? Or no, it became 7th grade, I think, after we did these big numbers. So now I need what? I got x and a 3x. I need a 3, right? Does that make sense? I need a 3. I need a plus 3. And 3 times x is 3x. I need to make what's there. So I'm going to subtract. Oh, 3 times -1. -3. Oh, and magic happens. Subtract. Oh, zero remainder, yay. If there was a remainder, I would, like, let's say the remainder was 5. I would write x squared plus 3x plus 3 plus 5 over x minus 1. That would be a fraction. Okay, and multiply that. Okay, so one of my factors is x minus 1. What's my other factor? X squared plus 3x plus 3. It was not dot dot dot, it was x squared plus 3x plus 3. Guess what happens if I multiply these two together? I get that. So one of my factors is x minus 1. Here's my other factor. Okay. Oh, I can keep going. This is called a quadratic. If that quadratic is factorable, I can find my other two factors. Okay, so I would factor this. Oh wait, it's unfactorable. This has no solution. In other words, it has imaginary solutions. So we have one solution at +1. X equals +1 is my first solution. My other solutions are imaginary. This graph has a y-intercept at -3. So this helps me graph the quadratic. Okay. Again, we can pull up Desmos and graph it if we wanted to. Or I could go to x equals 1 for the dot. Y-intercept is -3. 1, 2, 3 for the dot. Okay, and it's gonna look like the letter N. So it goes up, comes back down. Oops. Yeah. Comes back down and goes back up. Kind of like that. Makes the letter N. It looks pretty funky. Okay. It could possibly, I don't recall if it bounces right there, but it's similar to that. Okay, there's a sketch. So I'll look for a sketch. We could always pull it up in Desmos. Again, if that was factorable, if this was a 4, then it would be factorable. And then I could factor it and find the solutions by factoring. Okay. Or I could do the quadratic formula to find the solutions if they are not full numbers.
So is it always gonna be x minus 1 when we divide by, or will it be x?
No, so I knew one of the solutions was 1,
Oh,
just for this quadratic.
okay.
But we could it's called the remainder theorem. Okay. So there's a theorem for quadratics. We could guess some of our solutions for this quadratic. So my solutions are +, -1, or +, and -3. So all the factors of -3. So 1 and 3 are the only factors. Okay, it all depends on the last number and the first number. The remainder's theorem, or I think it's factor theorem, something like that. There's a theorem for this. So you could be guessing what the factors are to find this, to write it in factored form. Okay, because that's the goal, of write it in factored form. Once you write it in factored form, you find solutions. But that's a little beyond this class. That's something you'll get to probably in pre-calculus. But we want to be able to use long division, factor quadratics, so we can enable us to graph them. Okay. So long division. Want to do another practice long division? Yeah. Let's do another one. So just the long division, I'm just gonna write it up here in long division form. I might as well just do the problem from the assignment, problem 3. So it'll help you get started on the problems. Use long, oh, never mind. I'm not gonna do problem 3 because the factor is x minus 1. We just had that one, similar to that. So we got x, they use the division symbol. Number 4. I'll work you through this one. I'll give you the steps. Divided by x minus 5. I'm going to write it in division form. So there we go, this problem 4. On 5.4, we're doing log division, okay? So we're gonna figure out, oh, 2x. 2x times x is 2x squared. So 2x squared, we want to get that minus 10x. Do the opposite. Those cancel, that's minus. Oh, this is gonna be plus. Positive. I need to show it. Positive x, bring down to -5. Oh, hey, there's x minus 5, there's x minus 5. So we just got 1. I just, instead of factoring this, okay, I got 2x squared minus 9x minus 5. This is the problem, y equals. Let's factor it. Well, the factors are 2x plus 1 and x minus 5. What are the solutions? -1/2 and +5 are the solutions. That's the ultimate goal of what we're doing here. So they use the word the quotient and the remainder. And again, you can check your answer. Multiply that together. Multiply these two together to make that. The quotient and then divisor is called a divisor. So we multiply 2x plus 1 and x minus 5. When we multiply that out, we'll come up with the original quadratic. Okay. So this again works for cubics. This works for 4th degree polynomials, log division.
Would the solution be 1/2? And
-1/2, yeah. So a solution will be -1/2. I didn't. I was gonna go through synthetic division. I'm gonna do it real quick. It's like a shortcut. It's all right. Now we do synthetic division with can I do it with that? No, I need to do it with polynomials. It works for polynomials. So this is a factor. So again, the solution is 1. So the way it works, it goes like this. You put your solution in there. 1, 2, 0, 3. So whatever goes here is our remainder. So it's just a process. It just uses the numbers. 1, 2, 0, and -3 are constants. And we do multiplication and addition. So first thing we're gonna do is bring down this number. I don't think I assigned any of these or tested you on it, but it's just kind of another way of thinking about division. Bring the 1 down. We're gonna multiply the 1 times 1 and get 1. Just like over here. There's our 2 and our 1. And we're gonna add those two together to get 3. Then we're gonna multiply 3 times 1. 3 times 1 is 3. And we're gonna add those together. Right here, 0 and 3, added together gets 3. Multiply those together. 3. Add those together, we get 0. So that's our remainder. This is a remainder of 0. This means 1x squared plus 3x plus 3. The solution is x equals 1. The factor is x minus 1. And I showed that already. So it's synthetic division for this one right here. The factor is x minus 5, so the solution is 5. I'm gonna put the numbers 2, -9, and 5. 2, -9, and 5. So I bring down the 2. Multiply by 5 is 10. Add these together. Get 1. Multiply these together. 5. Add these together. Oh, it should be a -5. Add these together, I get 0. 2x plus 1. So synthetic division, again, I didn't assign any of these synthetic divisions because you just do long division. It's pretty cool operation, it's pretty cool system, learning something new, that's why you're here. Learning new stuff. It's exciting for me to find this puzzle. Piece to the puzzle, right? So again, I've been showing like the graphical part of all of these problems as we've been going. So again, I could go graph that if I wanted to, right? I got the intercepts. I could go graph this if I wanted to. Okay. I already graphed it, right? I did the little end looking thing, right? So it'll help us find the factors and find the solutions to be able to graph our quadratic, our third degree polynomial, cubic, our fourth degree polynomial.
And is there a time where you'd rather use synthetic over the long division or long division over synthetic, or does it matter?
Yeah. Well, good question. So I got that thing. X to the 6 minus 4x squared, or fifth, plus 3x to the 4 plus 2x squared plus x minus 9. Okay, one of the factors is 3. So let's divide this by x minus 3. Okay, have fun with all that. So I'm gonna use synthetic division. 1, -4, 3, 0, 2, 1, -9. Okay. Yeah, so when you got big old polynomials, 6-degree polynomials, bring down the 1, multiply, add, multiply, add, multiply, add, multiply, add, multiply, add, multiply, add. 21 minus 9, I can't do that math right now. 12. Alright, you got a remainder of 12. Yeah, and then you do synthetic division with all that. So you could pile them up if you really wanted to. But like I said, that's more of a pre-calculus thing. You might see it down the road, or in calculus use synthetic division, divide it polynomials to be able to find the factors, to be able to graph them.
And I remember, how about the one where it's like a over and a B over? I want to say it was up to long division, but maybe not. I can't remember. I'll find a test.
Oh, like a rational equation. Yeah, so if you don't just have whole numbers, you have letters. Yeah, that would work as well. So you could use synthetic division shortcut for that. Oh man, I gave you a lot of work time, I think, so later than I thought it was going to be. Hey, tomorrow we're gonna work through the next 2 sections of chapter 5. But the quiz I'm gonna give you is just gonna be 5.1 through 5.4. Okay, but that quiz will be due sometime on Wednesday. Even though we're gonna go through the next couple things, we'll do a bunch of review tomorrow. So I'm not gonna make it due tomorrow, it's gonna be due anytime on Wednesday. Okay, so because tomorrow we'll review all these 5.1, 2, 3, and 4. Hopefully you have lots of questions for tomorrow. Try to get on some homework sometime tomorrow. Unless you're working 6 a.m. to 6 p.m. tomorrow. Anybody doing that tomorrow? 12-hour shift? And then you're showing up there. 6 p.m. Yeah, so you can squeeze in some time. 20 minutes a day, keep bad grades away.
Yeah.
Put 20 minutes into it. All right, thank you. Have a great night.